Welcome to this session. This session, we are going to do an example on how to solve a problem on projectiles. So here's the problem. A particle P is projected from a point O on a horizontal plane at the speed of 28 meters per second with angle of elevation of projection of 30 degrees. After the projection, the particle moves freely under gravity until it strikes the plane at a point A. So find the greatest height above the plane reached by P. B, the time of flight of P. And C, the distance OA. So this question is testing on projectiles because of this condition here, that the motion of the particle is governed only by gravity. So the first step to do before solving the three parts A, B, and C is to draw a sketch to represent the information we have. So this is a vertical, and then this is horizontal. So let this to be the trajectory of the particle or the projectile. So I've been told that the initial velocity for this particle is 28 meters per second, the velocity with which the particle is projected, 28 meters per second. So this is our U, and this angle here is 30 degrees. So this is our alpha. So the first thing, part A, they want us to calculate the greatest height. So this, we call it H. What you know is that on this trajectory at this point here, on that trajectory, the point this is a point where the object reaches the maximum height. And then at this point, the velocity, vertical velocity, is 0. So the first part, maximum height. So the first thing, we start by resolving the velocity of projection components, both vertically and horizontal. So resolving the velocity of projection horizontally and vertically we have. Now for the horizontal, resolving the horizontal direction, then as we have seen in the derivation, the horizontal component or the velocity, the horizontal component of the velocity of the projectile is given by U cosine of alpha. And in this case, our U is 28, and then alpha is 30 degrees. And then resolving in the vertical direction, then Uy is given by U sine alpha, which is given by 28 sine of 30 degrees. So this we can get the answers. So this is 14.3 meters per second, 28 sine of 30 is 14. meters per second. So this is the horizontal component of the velocity. This is the vertical component of the velocity. And then we know that from linear motion equation, S is given by ut plus a half at squared. So in our case, maximum height, according to our diagram here, so this will be the vertical motion. So vertical is y, horizontal is x. So we can say y is given by uy t plus a half ay t squared. So ay is the vertical acceleration. And because in this motion, remember gravity acts downwards, so a becomes g. But when you revert the direction, moving upwards, then a becomes minus g. So we'll have y equals to our uy, we have gotten the answer to be 14, and then times time, and then this will be minus, so minus a half g, and then t squared. So which will be y equals to 14 t minus a half, and then value of g is 9.8 times t squared. So this will be y equals to 14t minus a half times 9.8, that's 4.9 t squared. Now, if we have the value of t, then we'll be able to get the vertical displacement. But also, since we do not have t, then we can use the other linear equation, i.e., we know that if we have v squared equals to u squared minus 2 plus 2as. So at this point here, where we have where the particle of the projectile is having maximum height, the velocity at this point, vertical velocity is 0. So it means that our Vy, or the final velocity for the vertical component, is 0. So V is 0, and then Uy, actually you can say Uy from our calculation is given by 14, and then to be the same thing, saying Vy squared equals to Uy squared plus 2ay, and then s. Actually, this s is what is the vertical displacement, so I can just call it sy. And then a, remember a is the same as negative g, because the object is moving forward, upwards, yet gravity is acting downwards, so this negative g, which is the same as negative 9.8, and then sy is the unknown that you want to calculate. So replacing, you'll have 0 squared equals to 14 squared. Now minus 2 times 9.8 and then times sy. Sy is the same as h in our problem, the vertical height. So this will be 0 equals to 14 squared. It's 196 minus 2 by 9.8. That's 19.6 sy. So it tells us that 19.6 sy equals to 196. Then divide by 19.6. Divide by 19.6. So sy, which is maximum height, h, is given by 196 divided by the answer, which is 10. So we get 10 meters. Or without doing all this one, we say that maximum height from our previous derivation of equation of projectile motion was given by u squared sine squared alpha over 2g. I remember our u initial velocity of projection was 28, and then sine squared of 30 degrees, and then 2 times 9.8. So 28 squared times sine of 30 degrees squared divided by 2 times 9.8. This still gives us 10 meters as the answer. So you can either use this long method, or you can just, if you remember the formula we derived for maximum height, put in the values we have in the question and get the answer. Next part is the time of flight. So time of flight is time taken to move from point O to A. So B, time of flight is the time taken for the particle to move from O to A. So that's what we have as the time of flight. And then, which means the time of the particle strikes the plane when the vertical displacement is 0. Now you see from this diagram here, so from this point, at this point here, on the x-axis, the value of y is 0. So once you have the y equation, then you can always calculate to get the value of t, where the equation for vertical motion is 0. And in this first part, we had already found out that this is the relationship. This is the relationship or the equation governing the vertical displacement. So which tells us that this implies that y should be 0. And then the equation for y from this calculation is 14t minus 4.9 t squared. So 0 equals to 14t minus 4.9 t squared. Now this is a quadratic, so we can factor out t. Then you have t into 14 minus 4.9, t equals to 0. So this gives us t equals to 0. Ignore this. So t equals to 0 with the, the value of t at, we are interested in the value of t at 0.8, or 14 minus 4.9, t equals to 0. So this implies that 4.9t equals to 14, which implies that t equals 14 over 4.9. That one gives us 2.857 142857. So roughly t is 2.857 seconds. So this is a time of flight. But also, in our previous derivation, we say that time of flight is given by t equals to 2u sine alpha divided by g. So which will be given by 2u is 28 times sine of 30 degrees divided by 9.8. So when you work out this one, 2 by 28 times sine of 30 divided by 9.8, you still get the same answer. T equals to 2.857 142857. So you can either use this this formula from what you derived previously, or you can go in the long way and still get the same answer. And then the last part is to find the distance OA. That's the range. Distance OA. That's the horizontal distance. So part C, we know that distance is given by velocity or speed times time. And time to move from O to A, we have calculated to be 2.857. So because we are moving along the x-axis or along the horizontal direction, in the horizontal direction, so this distance will be the same as ux times time of flight. And if you remember from our calculation, ux was given by 14√3. So we'll have 14√3 times time of flight is given by, actually the exact value here was 14 over 4.9. So 14√3 times 14 over 4.9. That gives us 40√3, which on putting as a decimal will give you 69.2820323 meters. So it is roughly 69.28 meters to nearest 4 significant figures. Or if you don't want to do that long method, you know that range from our calculation, range is given by u squared sine of 2 alpha divided by G. So this will be 28 squared times sine of 2 times 30 is 60 degrees divided by 9.8. So 28 squared times sine of 60 divide 9.8. You still get 69.2820323 meters. So either use the formulas we derived, or you can do it in the long way and get the answer. Thank you.